Okay, so last time I talked about lipids and how oils are soluble in water in some conditions. And I got to the topic of soap. Well, how soap works is that soap has a side that has an ionic charge, which makes it polar, and then it has a long fatty chain, which we would say is a non-polar chain. Well, how that works, we call those empipathic. That means they have a polar end and a non-polar end. What soap does, it helps water dissolve stuff like grease. So when you go to wash your dishes, you add a bit of soap onto whatever you use to wash your dishes, and when you apply it onto your dishes, on a molecular level, the water is the one that's actually cleaning your dishes, even though water technically can't break down any non-polar substances. But what the soap does is, since it has a non-polar end and a polar end, the polar end helps the water to get in contact with the non-polar end, and that makes the non-polar oil or grease soluble in the water by removing some of the tension that's between the water molecules. So at a molecular level, since we have something called hydrogen bonding between water molecules, which actually brings the water molecules quite close to each other, what soap does is it reduces that closeness between the water molecules and moves them apart. Kind of like if you have a carpet underneath you and you're standing on the rug and someone just comes and they pull the rug really fast underneath you and you just collapse. That's how it works with soap. When you have oil with water, most of you have seen that oil floats on water. If you were to add a drop of soap into it, it would reduce the tension between the water molecules, making a little space for the oil to actually fall through and make the water less dense. And that's how soap works. And using soap, we all know we can get oily stuff off of our dishes, even though the water itself doesn't actually do it. Subscribe to me and you will see a new video weekly. Please subscribe. Please. Just maybe.